In this video I am going to discuss about few important problems related to singular solutions. In most of the cases you can see certain differential equation will be given to you and you will be asked to find out singular solution if possible. Obviously if exists any singular solution you have to find that one, and obviously in some cases you have to additionally find out extraneous loci. So let us discuss about few important problems related to this topic. Say in each and every problem we have to find out the singular solution. I am going to abbreviate singular solution by writing it as S dot S, singular solution. So first problem is like this. Say we are going to solve this one, xp square minus 2py plus 4x is equal to 0. So first of all you can solve this one with respect to x, with respect to y. So we can write given equation can be written as 2py that is equal to xp square plus 4x. So simply find out the value of y. So that means divide this entire expression by means of 2p, so that you will get xp square by 2p plus 4x by 2p, so that you will get x by xp by 2 and then 2x by p. So this is the first equation you can consider. Actually if we differentiate this expression by x, then dy dx can be replaced by p. So we can write differentiating both sides with respect to x, we get dy dx, that is nothing but small p itself, and then on the right hand side you will get p by 2, then x by 2 dp dx. Along with it we have 2 by p and then minus 2x by p square, along with it dp dx. Just simply differentiate this entire expression. Now from here you can obtain the expression corresponding to some coefficient of dp dx and some other terms. So first of all you can consider this is equals to x by 2 minus 2x by p square. Within bracket you can put this one. Obviously this is the coefficient of dp dx, and then you can take the other side, this entire expression, p minus p by 2, so that will be p by 2, and then minus 2 by p. So this will be equivalent to, in the LCM you will get 2p and p square minus 4 in the numerator portion. So in the next line you can see, you can simplify this expression. So you can write p square x minus 4x by 2p square into dp dx, that is p square minus 4 by 2p. So simply you can write this one as x into p square minus 4 by 2p square dp dx, that is equal to p square minus 4 by 2p. Now you can take this entire portion on the left hand side, so that you can take p square minus 4 by 2p as common quantity. So within bracket you will find x by p dp dx minus 1. So we can take this factor in order to find out the general solution. So we can write so that x by p dp dx minus 1 equal to 0, and from here dp by p, that should be equal to dx by x. Now integrating we will get log p, that is equal to log x plus log c, so that it will be equivalent to p equal to cx. So you can see we have obtained another relation. For simplicity let us consider this is equation number 1 and say this is equation number 2. Now what is our objective? We have to eliminate p from equation 1 and 2. So technically we can replace this value in this expression, that is p square can be taken as c square x square and so on. So using 2 in 1 we get first component is what? X, then p square, then x p square means c square x square, then minus 2py minus 2 cx into y plus 4x. So from here you will get c square x square minus 2cy plus 4. So as you can see in this expression, you have already eliminated p, so you can consider this is the required general solution. Obviously c is any arbitrary constant, so which is the general solution where c is some arbitrary constant. C is the arbitrary constant. Say this is equation number 3. Now from here you can easily find out C discriminant relation, because this is a quadratic in C. So in order to find out C discriminant, simply you can use the technique of b square minus 4ac. So you can write now C discriminant relation gives b square minus 4ac, so that will be minus 2y whole square minus 4ac minus 4 into x square into 4, that is equal to 0. So 4y square, and from here you will get 16x square. So you can write so that the result will be y square minus 4x square. So say this is equation number 4. Now also let us find out the p discriminant. Already you can see from equation 1 the given question is in the form of some quadratic of p, so you can find out p discriminant from this relation. So also from 1 we get the p discriminant as, now here b square minus 4ac, that is minus 2y whole square minus 4ac. So that means you can have this type of structure, minus 4, a refers to x and c refers to 4x, so that you can say here also you will get same expression, that is y square minus 4x square is equal to 0. So from equation number 4 and 5 you will see both the discriminant relation will give you identical result. That means y square minus 4x square, this is the required criteria, or this is that required factor which occurs only once in both C discriminant relation as well as P discriminant relation. Now we all know in case of singular solution we have to identify only that factor which is present in C discriminant and P discriminant relation only once. So here you can say clearly from 4 and 5 we get y square minus 4x square equal to 0, that is y is equals to plus minus 2x is the required singular solution. So this is the answer for this first problem. Now moving on to the second one. Suppose we are considering this one, x square p square py 2x plus y plus y square. And obviously in order to solve this problem, first let us reduce it to the Clauser's form by taking some suitable substitution. Say y is equals to u and xy is equals to v. We are going to use this substitution. So first of all let us consider y is equals to u. That means dy should be equal to du and xy equals to v, so that you can say dv, that is x dy plus y dx, so that dv by du you can write in this fashion, that will be x dy plus y dx by dy. So x plus y dx dy, that means x plus y by p. Now for simplicity you can say this is p dash. That means you are assuming this dv du is equals to p dash. Now from here you can find out the value of p. So p dash minus x, that is y by p, so p will be y by p dash minus x. So this is one relation that connects p and p dash, and obviously we have to use this value of p in the main equation, that is in the given equation, because once you can convert p in terms of p dash, then you will be able to simplify it to obtain the general structure, which may be written in the form of chloride structure. Now say this is equation 1, say this is equation number 2. Now from 1 you can see this can be written as x square p square plus 2pxy plus y square, and separate this quantity py square. So this is xp plus y whole square plus py square. Now let us replace p by this quantity. So we can write xy p dash minus x plus y whole square, then y into y square, that is y cube, p dash minus x. So in the side note you can write we have used equation number 2. So now it's time to simplify this expression. So xy plus p dash y minus xy by p dash minus x whole square, y cube p dash minus x, that is equal to 0. So xy will be cancelled. So from here you will get p dash y by p dash minus x whole square plus y cube by p dash minus x, that will be equal to 0. Now simply multiply this expression obviously on both sides by p dash minus x whole square, so that this part will be cancelled, and on the second term you will get y cube into p dash minus x. That means we are trying to multiply, or we are going to multiply this entire expression by p dash minus x whole square. So just remember the term p dash y whole square will be there, and then y cube into p dash minus x will be there, so that we can write p dash y whole square y cube into p dash minus y, p dash minus x most probably, p dash minus x. This is equal to 0. So y square p dash square, and from here you will get y cube p dash minus x, that is equal to 0. That means this is the modified structure. Now we have to modify this entire expression by means of Clauser's form. Now how to modify this expression? Simply you can write this one like this, p dash minus this, so that you can obtain p dash y minus xy. Now remember, y is supposed to be u, xy is supposed to be v. So this expression can be rewritten as p dash square y is equal to u, and this part is equal to v. So you can write v in the form of p dash u plus p dash square. Now just remember, this is nothing but the Clauser's form. So we can write which is in Clauser's form. So as we all know, the complete primitive is given by v is equals to cu plus c square, but again v is equal to what? Xy, and u is equal to what? Y. So here you can say the solution is written in the form of like this. C is the arbitrary constant. C is any constant. Now this will give you the general solution. So this was equation 2 and we can take this is equation 3. Now clearly this is a quadratic equation in C. So C discriminant relation gives, you can consider this equation as like this. That means this is a proper quadratic equation in C. So you can find out the C discriminant relation. That is nothing but b square minus 4ac. So y square plus 4xy, that is equal to 0. So you can take y common, y plus 4x. Similarly, also if you remember the question, that is this one, from here you will be able to find out p discriminant relation, because this is a quadratic in p. So p discriminant relation will give you what? Y into 2x plus y whole square minus 4x square y square. So we can write y into 2x plus y whole square minus 4x square y square. So this is the p discriminant relation. So I can write in this fashion. Here p discriminant relation gives this equation. So simplifying this expression, you will get again certain structure. So you can write this one as y square plus 2xy, or simply you can write in this fashion, no need to modify this one, y square 2x plus y whole square minus 4x square y square. So simply take y square common, 2x plus y whole square minus 4x square. So from here you can say 2x plus y whole square into 2x whole square. So y plus 4x, and again you will get y. So in this fashion you have obtained y cube into y plus 4x equal to 0. Now again you will see, so this is equation 4 and this is equation 5. From 4 and 5 you can see this particular factor occurs once in both p discriminant and c discriminant relation, and consequently you can say this is nothing but a singular solution. So 4 and 5 we find that y plus 4x equal to 0 is a singular solution. So in this way we can solve the problems related to singular solutions. Here I have used two examples in which I have used Clauser's form, and I have taken some substitution in order to modify it into a Clauser structure, and in the previous problem I have directly solved that one. That was solvable for y most probably. Yes, it was solvable for y because I have expressed in terms of y and then I have differentiated with respect to x. Always remember one thing, whenever you are trying to express the entire expression in terms of y, differentiate it with respect to x, whereas if you are getting some expression corresponding to x, then differentiate it with respect to y, and dy dx is nothing but equivalent to p. So in this way you can solve this type of problems, and obviously if you go through this type of problems, definitely it will help you in the examination. And if you have any doubt, please show me your doubts in the comment box, then I will try to solve it. Thank you.